Hello, everyone. It's Miss Sabi here, and you're back for another video with STEM with Miss Sabi. My regular disclaimer, this is not going to be some professional video that I will edit, clean up, or anything like that. If my phone rings or something goes off in the video on my computer, you're going to hear it in the you're going to hear it in the video. If I make a mistake, it's going to be there. This is real. I'm not editing anything. So, welcome back. So today I was working with some brilliant boys at ACDPN. So that's the African Canadian Development and Prevention Network here in Montreal, Quebec. Shout out to Tanya and Yushana who are over there. They always treat me like sisters. I just love them. Anyway, so I was working with some brilliant boys, and we were looking at some of the grade 9 topics. And so we were looking at real numbers. Okay, so we're going to go quickly through the beginning part of this, but this video is mainly to talk about how we convert decimals into fractions, but more specifically, how do we convert those stubborn repeating decimals into fractions, right? So I don't even remember doing this when I was a kid. I only remember this technique. I only know this technique when I became a teacher. I don't even remember doing this. But you know what? We're gonna work through it. And the boys and I had a great time today doing that. It was like a little challenge. It was like a little mystery, and they loved it. So I thought I would make a video so that when we forget how to do that, we can always come back and take a look at that. Okay, so you know, defining what numbers are. We just know what numbers are, but if you're asked to define them, you're like, well, I don't know, you use the things that we use to count and stuff like that, right? So, what are numbers? Numbers are abstract concepts used to represent quantities, measurements, or values in mathematics and everyday life. They are fundamental to mathematics and have various types and categories, including, so this is what we will be looking at. So we're looking at real numbers in high school. Thank goodness we are not looking at anything else like the non-real imaginary numbers or whatever that when you go on to math and stuff, physics and all that stuff that's beyond high school, you're going to learn about like non-real numbers, but thank God we don't have to think about that in high school. So we have natural numbers, whole numbers, rational numbers, irrational numbers, and then all these things fall under real numbers. So, natural numbers is exactly like what it sounds like. What do we do when we naturally count? So, natural numbers are called the counting numbers. So, if I tell you to count, you're going to go 1, 2, 3, 4. You're going to go like that. You're not going to say, I'm not going to say, hey, count to 10, and you're not going to go -4, -3, negative, right? So, what do you naturally do when you count? Those are natural numbers. Whole numbers are the counting numbers, natural numbers, including zero, though. Okay. Sometimes you see definitions where natural numbers includes zero, but then how do we differentiate between natural and whole numbers if we do that? So for me, I call the natural numbers, those numbers, the counting numbers. How do you count? Rational numbers are any numbers that can be expressed as a fraction. Um, we will take a look at that. So as long as you can express it as a fraction, it's considered a rational number. Then you have irrational numbers. So I tell people, think about someone who's behaving irrationally, right? So it's kind of like uncontained and can't control it. So an irrational number is a number that goes on and on and on. It just keeps on going. You can't contain it. It's irrational. Okay. So classic example of an irrational number is pi, right? So on your calculator, yeah, pi looks like it finishes or it terminates, but it doesn't. Pi goes on and on and on and on and on and on forever. So it is an irrational number. And again, real numbers encompasses both rational and irrational numbers. So all these categories that we just spoke about, they fall under real numbers. Okay, so we have those definitions there, right? So I just described them. And again, just reminding you that for natural numbers, I know I got this definition from, I'm not sure which website, but I'm gonna like not include zero for natural numbers. I'm gonna just say the zero is contained in the whole numbers. We have integers as well, right? So integers are those positive and negative numbers, but they're not fractions, right? And it also includes zero, right? So whole numbers, and it could be positive, negative, zero. So if you are drawing a graph and you have a Cartesian plane, you usually number it by putting integers, right? So from left to right, you go from negative to zero to positive. Okay, so those are whole numbers. I mean, sorry, integers. And we talked about what rational numbers and irrational numbers are. Just also remembering that for rational numbers, when we say it can be expressed as a fraction, remember that you cannot put zero in a denominator. So as long as the integer that is on the bottom of this fraction is not zero, right? Because we all know that if you put it in your calculator, if you divide anything by zero, it'll give you math error because it's undefined, right? You can't divide by zero. Try it out in your calculator if you don't believe me. So there are symbols for these things, right? So natural numbers has this fancy N, integers has this fancy Z looking letter. And something important to notice is that we have the integers here, but this little asterisk means that you have the integers, but you're not including zero. So when we talk about rational numbers, which is identified by this Q, we say that it can be expressed as a fraction, but your B, which is on the bottom, is a number from set Z asterisk, meaning any integer as long as it's not zero. Okay. And irrational numbers is represented by Q prime. So we talked about that prime symbol with the boys. So prime is just is some like a variation of something. So just like if you had triangle ABC and you performed a scale, an enlargement and it was bigger, right? And you enlarged it by a factor, then the new triangle could be labeled A prime, B prime, C prime. So prime is something that we do see in mathematics. So now we are going to get to the actual reason why we are why I made this video. So I was reminding the boys on how we convert decimals into fractions. Okay, so again, we're addressing rational numbers, which can be expressed as a fraction, remembering that your b, which is the number in the denominator, cannot be zero. So there are two categories when we're talking about expressing, converting decimals into fractions. We have this nice category where we have terminating decimals. What does that mean? Well, if something is terminating, that means there's an end to it, right? So it's not repeating, it's just a regular decimal, no biggie. This technique you learned in elementary school. So I don't know how you learned it, but I always teach my students, whenever you see a number, it can always be put over one, right? So there's this imaginary one. We don't need to put it because anything divided by one is itself. So we don't normally put it, right? So we know that we've expressed it as a fraction, but you know that a fraction, you cannot have a decimal in a fraction, right? So you can't have a fraction within a fraction, technically speaking. So what am I going to do to get rid of that fraction? I'm going to move the decimal place one space. And we also know that when we move things one space or how many space, every jump is times 10, right? So always remembering as well, I can't just change one thing in a relationship and not change the other. So what I do to the bottom, I have to do, sorry, what I do to the top, I have to do to the bottom. So let's just pretend there was some 1.0, and then I'm going to move that decimal place like this, right? So I'm multiplying by 10. So what I end up having is what? So I move the decimal place one place on the top. So that is 5. And then I move the decimal place one time on the bottom. So what I end up with is 5/10. Now you should immediately look at this and be like, I think I can reduce that. So what is the greatest common factor between these two, 5 and 10? Well, I can divide them both by 5, right? So when I divide them both by 5, I get 1/2. So 0.5, which we do know as a half. These are small numbers. You know these things. So 0.5 is 1/2. That is the fraction. Now, the great thing is I have these calculators that I always tell my students to get these. I don't know if they'll let you show that, well, with my virtual background. It is a Casio natural display. And the great thing about this is if you were to put 5/10 on the calculator, so I don't know if you can see that I have 5/10, and press equal, it will reduce the fraction for you. So right now it is saying 1/2. I always encourage my students to get this calculator because it's half the battle. Like all those things, like remembering GCF and all that stuff is tested in grades 5, 6, 7, and 8. So when you get into those higher grades, it's obviously you should know how to do these things, but we shouldn't waste time trying to find GCFs and stuff like that. So if you have a calculator that is going to do that for you, fantastic. And also the reason why I like this Casio calculator is because it shows you the fractions and everything in a natural display. So when you have a fraction, you have a numerator on top, denominator on bottom, and the line in between, and it shows it to you like that. It doesn't do those weird things like some of the other calculators. So I really do encourage people to get that calculator. All right, second example. So we have 2.75. So again, I'm going to do the same thing. I'm going to put the 2, let me change my pen. I'm going to put the 2.75 over 1. And then how do I get rid of the decimal place? I move it once, twice, right? I move it twice. That will get rid of the decimal place. And what I do to the bottom, sorry, again, what do I do to the top? I have to do to the bottom. So if I do 1, 2, I now have 100. So you should look at that right away and know that that can be reduced. I'm not even going to think. I'm going to put that in my magic calculator. So when I did 275 over 100, the answer it gave me was 11/4. Now that I know that, I can go back and show my work and figure out what that GCF was. So 275 divided by 11 was 25. So what that means is I divided the top and bottom by 25 to reduce this fraction. So 2.75 is actually 11/4. So we have an improper fraction here. I won't change it to mixed because that's not what this lesson is about, but you could change it to a mixed fraction. Okay, so that is how we convert decimals into fractions if they are terminating, meaning they don't go on and on forever. But unfortunately, as you know, as you've seen on your calculators and you've encountered before, there are situations where you have a decimal that is repeating. Okay, so it doesn't end, it just has a pattern that repeats over and over and over again. So over here, we have 0.3, and this bar on top means that that's what's repeating. Okay, over here, the bar is across this whole sequence of numbers. So that means these numbers repeat themselves over and over again. Same thing over here. That means the 2 is repeating over and over and over again. So there is a technique to do this. Again, I don't remember doing this when I was younger. This is something I learned when I became a teacher. I don't remember having to do this, but there's a technique, and it's not something that's common sense and you just know how to do it. I mean, I'm sure there are students who are brainiacs and figure that out, but it's not something that's easy, and it's challenging at first. But once you get the hang of it, it is not too bad. But it's not a short process either. It's not something that's instantaneous and as quick as the other way to convert decimals when you have terminating decimals. So we're going to look at those steps, and then we're going to do it. So one thing that's important to remember is this word period or periodicity, whatever you want to call it. A period, it means something that is recurring, right? So you'll see that in math, right? Some kind of recurring, repeated pattern. So first thing that you do, so we're going to talk about the steps generally, and then we're going to apply them. Okay, so set the repeating part of the decimal. So set the decimal area equal to x. So first step, you're creating an algebraic equation. So that's the first algebraic equation that you are creating. To determine the period, right? So you're looking at, okay, what are the numbers that are repeating? Okay, so when you find the numbers that are repeating, count how many of them are there. So how many numbers are in this period? How many numbers are repeating? Okay, and then you take that number and you put it in the exponent part of 10. So 10 to the power of that number. Now that you have that number, you are going to multiply each side of equation 1 over here. You're going to multiply each side of the equation by 10 to the power of n. So sorry, this should read 10 to the power of n. Okay, so that is the number that you're multiplying both sides. So now you've created a second algebraic equation, right? So algebraic equation number 1 is up here, and then you've created algebraic equation number 2 by multiplying both sides of this by 10 to the power of n. Then you're going to subtract equation 1 from equation 2, right? You're going to find the difference, okay? Because when you're doing this step, we're going to see is that you're trying to trap that repeating decimal and kind of like get rid of it. And then you solve for x. So those are the general steps. Now we're going to apply it to the examples that we mentioned above. Okay, so we're going to try example number 1, where we are converting 0.3 bar, which means 0.333333333, which is going on. We are going to be converting that. So step 1 says that you are going to create equation number 1 by setting the repeating decimal equal to x. So I have x is equal to 0.333. So I'm going to write out some of the 3's, and then you get the point. It is repeating. So now I have equation number 1. Step 2, you have to determine the period. So what are the numbers that are repeating? So for this, the only number that repeats is 3. So 3 is the only number that repeats. So 3 is the only number that repeats, right? So the n that we speak of is equal to 1. We only have one number that repeats. So that is 10 to the power of 1, which is just 10, right? Then we're going to take the 10 to the power of n. Sorry, this should say to the power of n. And we're going to multiply it to the equation number 1. So remember, equation number 1 was this. 0.333 repeating. I'm going to multiply the entire equation by 10. So that means that's going to get multiplied by 10, and this is going to get multiplied by 10, right? So that's just the distributive property. So we end up with 10x is equal to 3.333 repeating, right? So that goes on and on and on. So I'm going to put that there. Equation number 2 is this, right? Repeating. Step 3, we're going to subtract equation number 1 from equation number 2. So equation number 2 is this, right? And that goes on. Equation number 1, if you go back up to the top, it's over there. X is equal to, so this is equation number 1. So now I'm going to put that over here. X is equal to 0.3333. I'm remembering we're subtracting. So you're going to be taking this away from that, this away from this. So the brilliant thing here, what happens is you'll notice that because these are all going on and on, that cancels out, like that goes away, right? So what am I left with? I am left with 9, wrong pen. I'm left with 9x is equal to 3. Okay, now solve for x. So if 9x equals to 3, what is x? So I'm going to isolate that x. So I've got to get rid of the coefficient. So the coefficient's 9, divide both sides by 9. So what I'm left with is x is equal to 3 over 9. Right away, you should see that that can be reduced. So divide by 3, divide by 3. So drum roll, please. We have 1 over 3. So now when you put 1 over 3 on your calculator, 1 divided by 3, you should see 0.33333333333333333. Okay. So that is example number 1. Not too bad. It looks really long also because I've explained every step in words or whatever. But once you get the hang of it, you can kind of like bam, 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 do the steps one after one another. But for now, write the steps out, fill in the information. All right, so now we can go on to example number 2, which is a little bit, a little bit more involved because your period is very long. You got a lot of repeating numbers. So again, step 1, set the decimal part equal to x. Okay, so we have x is equal to 0.1428571, 1428571, and so on and so on. Okay, determine the period. So what is repeating is all of these numbers. So the period is 142,857. There are 6 numbers. So again, the period is 142,857. There are 6 numbers that repeat. Okay. So then our 10 to the power of n is 10 to the power of 6. And sorry, I gotta fix that again. Okay. Then we're gonna multiply both sides of the equation number 1 by 10 to the power of 6, which is a million, right? So we're going to rewrite our first equation x is equal to 0.142857142,857, and that's going to be multiplied by 10 to the power of 6. And remember, that's going to distribute everything over here. Okay, so what I end up with is 2, 3, 4, 5, 6. X is equal to, so this here, we're going to jump 1, 2, 3, 4, 5, 6. So I end up with 142,857.142,857, and that repeats. And then, so I'm going to write it over here. Can I fit it? Let's see. 2, 3, 4, 5, 6. X is equal to 142,857.142. You get it, 857. It's tiny. You get the idea. So that's equation number 2. This step here, we're going to subtract equation number 1 from equation number 2. So again, equation number 2, 142,857.142,857. Equation number 1. Then we have x is equal, let me change that color so that we can see that they are 2 different equations. So x is equal to 0.142,857. And we know that on the top and the bottom, that is repeating. Okay. So when we do a million x minus 1x, we end up with 999,999. X is equal to, and remembering the good old thing is that these decimals cancel out. Okay. And we end up with 142,857. So today, one of the brilliant boys, DeAndre, pointed out, he's like, Miss, when we get to this step on the other side of this new equation, he's like, we always have the repeating decimals as a whole number. And I was like, that's a really great observation. That is what happens, right? So that period that was in the decimal part, repeating decimal part, you end up with that alone as a whole number, which is a great observation. So now we are going to solve for x. So let me just copy this. I'm being a little bit lazy. So how do I solve for x? I am going to divide both sides by 99999. And great thing about my calculator is that it will give me the reduced fraction. So 142,857 divided by 999,999. And it gave me 1/7. So you can try that out on your calculator. When you do 1 divided by 7, it should give you 0.142,857 repeating. Okay, so that's example number 2. Then we have one more example, and then I'll let you go. All right, so the next example is, I'm showing this example because it's a little bit different because we have a repeating decimal, but we also have what's before the decimal place, which is a regular whole number. So when I was working with the boys, they were like, well, Can I set the whole thing equal to X? And I just reminded them about what we're doing here. So we're trying to convert repeating decimals into fractions. So remember what a decimal number is. So this here is you have a whole number 1, and then this part here that's after the decimal, that's really a fraction, right? So you'll end up with some kind of mixed fraction where this will be 1, and then you'll have some other fraction, A over B, right? So what we are trying to figure out is the A over B part. So for now, we're just going to leave the 1 alone because it's not the problem. It's not the repeating decimal, right? The 1, it's not a problem. It's the point 2 part. So we're going to set the repeating decimal part of this number equal to X. Okay, so then we have X is equal to 0.222, and we know that it goes on and on forever. Determine the period. 2 is the only number, so the period is 2. The only number that repeats is 2, so n equals 1. So 10 to the power of n is 10 to the power of 1, which equals 10. Then we're going to multiply both sides by the 10 to the power of n, which is just 10 for us. So our equation was x is equal to 0.222, etc. Multiplying everything by 10, right? So the left and the right gets multiplied by 10. So we have 10x is equal to 2.222, repeating. So now we have equation number 2. I'm just going to drop that there. Then we're going to subtract equation 1 from equation 2. So we'll write that out. 10x is equal to 2.222. And then the other equation that we had, equation number 1, was x is equal to 0.222. And when we say subtract, right, this is like in brackets, so everything in there gets subtracted. So remember, when you have a negative sign outside some brackets, everything inside changes signs, right? So this becomes negative x, this becomes negative 0.2222, repeating. Again, remembering, great thing about that is that repeating part disappears now. That's why we're doing this work. We're trying to get rid of it. So then we have 9x is equal to 2. And then we'll put that over here. We'll have 9x equal to 2 because we're going to solve for x. So we're going to isolate that. Right? So then we have x is equal to 2 over 9, right? But that is just remembering we're trying to convert sorry, let me just get this to, tell me why this is not scrolling. Anyways, we are trying to get we are trying to get this number 1.2222222 into a fraction, so we can't forget the other part. So we had, why is this not scrolling? Anyways, so we had to convert, I'm going to do it over here. So we had 1.2 repeating, right? So we figured out the 0.2 repeating part. So our fraction is exactly 1 and 2 over 9. Now, what do I do with that? You can leave it as a mixed fraction, or you can turn it into an improper fraction. So how do we turn that into an improper fraction? We are going to do this times this. So 9 times 1 is 9. Then you're going to add this, which is 9 plus 2, 11. And then you're going to put it over the denominator. So now when you put that in your calculator, so I'm going to do 11 divided by 9 on my calculator, it gives me 1.2 repeating. So it is the correct answer. So we converted 1.2 repeating into a fraction. So remembering that the one, we forget about the one when we do this whole technique to convert into a fraction, because the one is the whole number. It's not repeating. It's not the problem. It was the 0.2 repeating that was the problem. So we did what we did the technique to find out what the 0.22222 represents in a fraction form. So that was 2 over 9. So our answer ended up being 1 and 2 over 9. And then again, I can convert that mixed number into an improper fraction. So we ended up with 11 over 9. So I hope this video is helpful to those of you who have to learn how to do this. It's always there for you. I will drop my notes, the link to the notes that I am working on in my Notability. I will put it in the notes part of the YouTube video. Again, thank you so much for hanging out with me. I'm sorry if this video is long. And again, shout out to ACDPN, Tanya and Yushana for allowing me to work with the brilliant boys that are affiliated with the association. It's always a great time when I go over to ACDPN. As you all know, I have a STEM with Miss Sabi learning space. So now I do all my tutoring there. When I get the opportunity to go to great organizations like ACDPN, I get up and I leave this done with Miss Sabi learning space because I love sharing spaces with other people. It is fantastic. So you all take care. Have a great 2025-2026 school year. I know a lot of you all are starting school soon. It'll be okay, right? Especially if you're going into grade 9. The key thing is do not procrastinate, do not put things off, do everything. As you get something, an assignment, nip it in the bud, plan it out. Do not drop the ball. You've got to be on it from the beginning. Um, and just ask for help. Ask for help. And if you need extra tutoring, come see STEM with Miss Sabi. Take care.